Now, we're always searching for more force, right? I want to smash through this wall. I want to smash through this concrete. I want to launch off of something. And normally, to get more force, well, maybe you have more gearing or you have a longer lever. And that's all good and well. That's the whole field of, how do you use statics, leverage, orientation from a load to a point to give yourself more force pushing on something. But there's a whole different direction you can go. And that is how quickly you apply a force, how quickly you apply a change in momentum can actually give a massive force for a really small amount of time, and that's called an impulse. Now, conservation of linear momentum finite form, all it is saying, let's say we have a baseball, a system, the mass of the baseball is the system, and it's flying through the air with some initial velocity, and then it's flying through the air with some final velocity. Now, velocity means a speed with a direction, so maybe the direction changed. Okay, so we have a final minus an initial, and it equals the during. And the during is what caused that change in velocity, and that's the impulse. And now that's actually a force times a time. The baseball was flying towards the bat, and then boing, it was flying the other way away from the bat. What happened between there? It happened over a very small amount of time, right? It was just in contact, and then bam, it was flying the other way. So we know something pretty ferocious happened there, and it was a phenomenally high force. Even though that baseball wasn't like, a rocket ship size mass, it was just a little bitty mass, but it changed direction so fast, there was a huge spike in force. And so what we're doing here with that jackhammer,
I thought this was about baseball.
You have a small mass, relatively small, that's going up and down really fast, and it keeps changing direction. It keeps bashing that thing up and down and up and down. And the shorter amount of time that momentum has to change directions, the force just shoots up. This jackhammer's pretty heavy, but me just gently going bash, 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 bash. There is some impulse being applied on that concrete, but if we could make that way more rapid to where the mass that's moving up and down and stopping and changing directions in here does that in a half a gazilla second, then we would have an infinite force, right? Because that right-hand side of the equation, the final minus initial equals during, if you make that time infinitely small, well, the force has to get infinitely big to make up for a change, any change in that momentum, that final minus initial on the left-hand side of the equation. So we can do some powerful stuff, not by getting more leverage or more torque and so we can get more force. No, we get more force just by making the amount of time that change in momentum has to happen over really small. That's the whole point of smacking something. That's why we use an impact on a nut. We go, bah! It's really fun. That's why we use a jackhammer. And so that's how we can bust through this concrete, is not that there's a massive mass changing its direction, but there's such a small amount of time that happens, and it's just going, bah, 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 and it chunks through anything in the world.